Regression discontinuity uses a running variable and a known threshold that changes treatment assignment. In a sharp design, crossing the cutoff determines treatment. In a fuzzy design, it changes treatment probability without perfect compliance. Units just below and above the threshold should be comparable, so assignment is locally as good as random if they cannot precisely manipulate the running variable. The effect is identified by a jump in the conditional mean at the cutoff. The two panels distinguish the designs visually. In a sharp discontinuity, treatment probability jumps from 0 to 1 at the threshold. In a fuzzy discontinuity, it rises discontinuously but remains between 0 and 1 because some units do not follow assignment. The first estimates a local effect directly from the outcome jump. The second uses cutoff assignment as an instrument for treatment and divides the outcome jump by the treatment probability jump. For a sharp design, continuity of both untreated and treated potential outcome functions at the cutoff implies that the observed jump identifies the local average effect at that threshold. Sorting is the main threat. If individuals can manipulate the running variable to cross the cutoff, units on the two sides may no longer be comparable. Grade inflation just above an admissions threshold is an example. Density and covariate checks help detect such failures. The graph shows the sharp estimate. Fit the relationship between outcome and running variable separately on each side of the cutoff. Extrapolate each local fit to the threshold and measure the vertical gap. The slopes may differ, but the treatment effect is the difference between the two intercepts at the boundary. Observations far from the cutoff should not determine this local comparison, which is why bandwidth choice matters. Within a chosen bandwidth, estimate separate local linear functions on either side. A small bandwidth reduces approximation bias but uses fewer observations and raises uncertainty. A large bandwidth improves precision but risks a poor local approximation. Data-driven selectors and robustness checks help, yet no one bandwidth removes the trade-off. Report the chosen window, local polynomial order, kernel, and sensitivity of the result to nearby choices. A fuzzy discontinuity is an instrumental variable's design near the cutoff. Define assignment by whether the running variable crosses the threshold and use it as an instrument for actual treatment. The reduced form is the jump in outcome. The first stage is the jump in treatment probability. Their ratio is the two-stage estimate. Under continuity, exclusion, and monotonicity, it identifies the local average treatment effect for compliers near the cutoff.